Using this demonstration website by H2O AI, I would like to show how you can chat with documents. Now it's important to stress that this is a public website, so please do not submit any sensitive information. Before we get started, there is a setting I would like to tweak first. Now the setting here is the temperature. The temperature determines how deterministic your responses would be. I will set this to 0, or at least as close to 0 as the UI will allow me. The reason for setting this value to 0 is especially important in a production environment where, for example, when you have two customers asking the same question, you expect the model to generate the same response. This is also very helpful in debugging. With this out of the way, let's move on to ask a question I might be interested in. Now once I hit enter, you will see the responses starting to generate. Now is a good time for us to look at the different models it's using to generate the responses. You will note it's using a couple of variants of the Llama 2 model, including the large 70 billion parameter model. We can see how this would be a very effective tool during early phases of our development. We can easily compare the responses between different models. For example, we might think we need the large 70 billion parameter model, but maybe the 7 billion parameter model would work just fine. It's also comparing between different types of models. For example, at the bottom you'll see it's testing some of the Falcon variants. Let's now have a look at the response from the 70 billion parameter model and see if there's something that piques my interest. Time series analysis. This is a topic I'm quite interested in, specifically time series analysis with regards to anomaly detection. The second point listed there is generative models, also quite in vogue currently. So these might be topics we are interested in for further research. Now let's find a few research papers we might be interested in and with which we are going to chat next. I'm going to find these papers via an advanced search, typing in the keywords I know might be relevant. I will be searching in the abstracts. Finally, I want my anomaly detection specifically with GANs. That sounds like something that could be quite interesting. Let's see what we get. The results look quite interesting, and it definitely looks like a possible approach. For this demonstration, I'll just be picking the top 3 articles. So let's open them in a new tab. These papers can be uploaded to our model to chat with. We will expand the upload section. Now you'll see in the upload section, you can simply drop your files here. Now these files can be a number of formats, including PDF, plain text files, and markdown files. Conveniently, this user interface also allows us to just set the URL for the paper we are interested in. Let's do that next. I'll start with the first paper. Now it is going to take a few seconds to process. So let's leave that to run for a little while. If we scroll down a little bit, you'll see in a moment that it will tell us there's one document in our collection now. It is currently in a queue because what it's doing in the background, it's now splitting into chunks and storing it into our vector database. Okay, let's add the next document. And the same thing will happen again. It will grab the content, it will do the embeddings, split it into chunks, etc. Okay, the final document we'll be using. While this is uploading, we can quickly have a look at what the document section looks like. Firstly, in our document selection, this shows us which documents we're going to chat with. Right now, we only have a single collection named My Data. In My Data, there are the 3 documents we would expect. Can we look into these documents? Of course we can. We can go to the document viewer section. I will select one of the papers we selected previously. When I view this, you can see this is definitely the content coming from our research papers. Sometimes you might notice funny symbols like this. This might be from equations or images that could not be read otherwise. This is normal. Let's have a look now at seeing if we can find some of the metadata for these documents that's stored. To see that, we click the View Database text. And let's select the second document for example. Now we can see the metadata that was stored for this PDF file or this paper, and we can start to see some of the chunks that was recorded. So here's the first chunk. It's quite a big chunk. Another chunk, a little bit smaller, etc., etc. Now the chunking strategy is obviously up to the back end of this demonstration site, but I think you get the picture. Let's return to our chat and now ask it some questions. What we expect now is it will get information from these papers and use that to synthesize a result. Let's ask it a straightforward question of how do I use GANs. Okay, well, hopefully we will now see responses generated using these papers as context. Okay, we can already see a response coming up on the 7 billion model. That looks quite interesting. If we look at, for example, this ALGAN, that was definitely something from a research paper. In fact, this very first one over here. So that is good. We're using our context. If I scroll down a little bit more, we can also see under sources where it will tell us which papers were retrieved to generate the output. And in this case, we can see this 1, 2, and this is the same one. So it's 2 of those papers that were used to generate the output. I'm certain by now you're starting to get the idea of what's going on. We've seen how this tool allows us to compare the output of various language models side by side. We've also had a look at how you can chat with your documents. Chatting with your documents is actually a multi-step process. In the background, it extracts the text from your documents, split them into sections, and these are then later used to provide context to the model when you're asking a question. In a future video, we'll look at how we can do this in code, and you'll see how there's a little bit more to this. We'll talk about things like embeddings, chunk size, overlap size, etc.